Welcome back for day 2 of section 2.3. We're going to continue our conversation on linear functions in slope-intercept form. All right, this time we're going to add a learning target of finding intercepts of lines. Okay, so that's going to be one of our new skills today. Otherwise, the rest of it is still just talking about slope-intercept form and graphing in slope-intercept form. An important skill that we're going to need basically throughout the rest of the course, yet again, is talking about excuse me, converting equations to slope-intercept form. Because you can be given a huge nasty equation that is a linear function, but if for any reason you need slope or y-intercept, anything like that, you really need the slope-intercept form. So first let's talk about how do we get it to slope-intercept form. So getting it to slope-intercept form basically means solving for y. Okay, that's going to be the ultimate goal here. So for example, in this one, I want to solve for y. I want to get y by itself. So the first step, I'm going to move the 5x away. All right. So by moving the 5x away, I'm still left with the negative 4y. Now the negative 5x can't combine with the 16 because obviously they're not like terms. So I just leave them separate. Okay. Now, final step, still trying to get the y by itself. I need to divide by the negative 4 that's with it. Excuse me. To get y equals, here negative divided by negative cancels. So I get 5/4 x. 16 divided by negative 4 is going to be minus 4. And now I have a slope-intercept form, so I can much easier see the slope is 5/4, y-intercept at negative 4. What about this next one? What can I do to get the y by itself? Well, the first thing is slope-intercept form. There's no parentheses or anything like that. So the first thing I would note here is if I'm trying to put it into slope-intercept form, is I'm going to distribute that 3. Okay, so I'm going to distribute the 3. Now, I'm going to add that 2 away. Now, obviously, the 2 doesn't add to the 3x because they're not like terms, but it adds to the 3 that's on its own. And now, once again, I have that y by itself, so I can see the slope is 3, and the y-intercept is at 5. Now, this next one looks a little bit intimidating because of the fractions, but let's think of the same steps as we used for the first one. First step, I need to get this 3/4 x to the other side. Okay, I don't want that with my y. So I have 1/2 y equals, and again, the 3/4 x can't combine with just a normal number, so I have to go like that. Okay, I need to leave them separate. Again, the goal was the same. I had to move the x term away. Now I need to get rid of that 1/2. So remember, you could divide by 1/2, but that sounds a lot harder than, couldn't I just multiply everything by 2? And that gets rid of the 1/2. So that's how I'm going to view this. I'm going to multiply my whole equation by 2. So that's going to cancel 1/2 that's with the y, okay, getting rid of that denominator. 2 times 3/4, well, that would be 6/4, which would reduce to 3/2. 2 times negative 1, give me a negative 2. It multiplies the entire equation. And now, once again, I have an y-intercept form, so I can see the slope is 3/2 and the y-intercept is negative 2. Okay, so that's going to be really important. Can we get things to slope-intercept form? One of the main things, or the main reasons it's important, is I could ask you to graph an equation of that form. And again, the best way to do it, get it to slope-intercept form, and then go from there. So for example, this first one, if I want it in slope-intercept form, move the x away. Can't combine with the 1, so they stay separate. And now this one is actually already in that slope-intercept form. Okay, and that I know how to graph. Okay, I know that I start at my y-intercept of 1. I know I have a slope of 2 over 1. So I go up 2 over 1, and then I can even continue, oh, yes, I continue it down in this direction, so I can, as accurately as possible, sketch my line. And same thing with the next one. So again, the way that we know to graph is by getting y by itself, putting it in slope-intercept form. So I'm going to move my x over. Which stays separate from the 14. Now this one I have the additional step. I need to still get the y by itself. So now I'm going to divide everything by -7. Negative divided by negative becomes positive. So that's 4/7 x. 14 divided by -7 would give me a -2. And again, the reason we do this is in this form, now we know how to graph it. Okay, I can see my y-intercept at the -2. I can see my slope, 4/7. So up 4, 2, 3, 4 over 7, 2, 3, 4, 5, 6, 7. And I'm going to do the same in the reverse. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Sorry, touched my board when I shouldn't have right there. You can now see where your line is and can connect the points. So in this section, graphing is exactly the same. I just need you to know how to convert it to y-intercept form first, or slope-intercept form first, and then graph it from there. Now, the cool thing is, hopefully you know, the graphing calculator can actually do this for you, right? So let's just take a little bit of practice because I love when you can check your work. I want you to know the math, but I also want you to be able to check your work as you go so you can be confident that you're doing it right. So, graphing calculator. In order to graph on it, you need to go to y equals. So that button right there, that's now highlighted red because I just tapped it. That's where you go. And now notice all of them are in y equals already. Okay, so y equals, the example in your packet is -3x plus 7. So I need -3. Now, notice where I'm pressing for the x. Okay, that's where you always go when you're graphing. That is your variable for your graph. Okay, so know that button. Then plus 7. Okay, so you just type it in as you see it, then hit the graph button, and there you go. So this is a very effective tool for checking your work. You do need to know how to graph it by hand, obviously. This is not a replacement for graphing it by hand. This is just a tool so once you do it, you can check your work to convince yourself that you're right. Now, there is one stipulation to this, okay? So it only graphs when you have it in that y equals format, okay? So before you can graph anything, you do need it in y equals form. Then you can type it in and check your work, okay? So just a little snippet on how you can be checking all of your stuff with your calculator. Now, moving on to the next concept. So x-intercepts and y-intercepts. So x-intercept is where you cross the x-axis, okay? And it's always in the form x, 0, okay? So wherever it crosses, and then the y value is always 0, okay? So that is your x-intercept. Y-intercept is where it crosses the y-axis. So here, your x is going to be 0, and then you would have whatever y value is that it crosses at, okay? So the thing to keep in mind is whenever you're talking about an x-intercept, x is a number when y is 0. Y-intercept, y takes on the value and the x is 0. So just remember that whatever you're looking for, in x-intercept, x actually has a number, and the opposite one, the y is 0. For y-intercept, the y is the value, y is the number, and the opposite one, the x, is going to take on the 0. Okay? So just make sure you know that in the name is the other one that becomes 0, the opposite one. Okay? So let's practice finding some intercepts. Okay, so graphically should be pretty easy, right? So here, this would be my x-intercept, right? And the x-intercept, well here the x value is back at -2, and the y value is 0. Here, my y-intercept, the x value is 0, and the y value is -1, 2, 3, 4, at -5. So graphically, you're just looking for where it crosses, all right? So let's think about equations, though, okay? So for equations, when I'm looking for the x-intercept, remember the x-intercept is going to be when you have an x value and your y is 0, okay? So what that means is to find it when you have an equation, you're going to plug 0 in for y, okay? So just plug 0 in for y and now solve. So I'm going to subtract the 5, divide by 3. So my x-intercept is at -5/3, 0. The y-intercept is going to be at 0 and then some y value. So this time, remember, the x is going to be the 0. The opposite one is the 0. So I plug 0 in for x, and I just get 5. So my y-intercept is going to be 0, 5. So you can find them looking graphically, or you can find them in equations if you just plug in the 0. Okay? So let's take a look at this next one. So I got x-intercept. X-intercept is going to be some value of x when y is 0. So x-intercept, I'm going to plug in 0 for y. So that's going to completely drop out of my equation. Now I'm just going to have an x of 6. So that's going to be my x-intercept. Again, the opposite one becomes 0, so I'm actually solving for an x value. Y-intercept. Remember the opposite one is 0, so my x is 0, and then I'm solving for a y value. So this time I'm going to put 0 in for x. So it drops out completely. Divide by -4, and my y-intercept is going to be at 0, -3. Now, this idea of intercepts actually goes a little bit deeper. Okay, so with intercepts, you can actually solve really cool equations. Okay, so think about this type of an equation. You saw that back in chapter 1, right? And we would make you solve it. Okay, but now I want you to think. Okay, so in solving it back in the chapter 1 method, you would have distributed that 2 combined like terms, subtracted the 14, divided by 2. Okay, so pretty easy. This was a pretty basic one back in chapter 1. However, we're going to get some hard equations. So a good way to check your work is to think about this idea, okay? That if I have an equation that looks like this, picture the 0 as y. Okay, so basically when you're talking graphically, if I'm picturing that 0 as a y, basically what I'm looking for is the x-intercept, because remember the x-intercept is where the y is 0. So what I want you to see is you can actually solve this graphically. So notice here, I've already graphed it for you, but look where the x-intercept is. The x-intercept is at x equals -7, which is the solution to the original equation. So you can check your solutions to equations when you're having to solve. You can check them graphically because that 0, if you picture that as y and you graph it, well, all you're looking for is the x-intercept, and that's going to be the solution. You can even do it for harder ones like this, okay? So any equation back in chapter 1, if you can get it to equal 0, so here if I subtract that 3 off and I subtract that 5 off, okay, if I get everything to one side, I can picture this as y. Okay, and when I do that, basically graphically all I'm looking for is the x-intercept, and that's going to be my solution. So let me show you. So here, I'm going to go back and graph this. 2 times x plus 1. Oh, I'm sorry. I'm really messing up typing here. X plus 1 minus 3x minus 5. And I just want to make sure I wrote that right. Yep. And if I graph that, it shows me right away that the solution to that original equation is x equals -3. So by graphing it, I could actually solve that original equation instead of having to go through all that chapter 1 work. Not that that work is necessary, but I'm saying this is a way to check your work. And this will help you later on if you start getting this idea that when an equation is set equal to 0, basically is finding the x-intercept, okay? The solution to that equation graphically is the x-intercept. All right, so hopefully you found a lot of this interesting, okay? Kind of relating it back to the material that we've already covered in the course. So I want you to take a moment. Please, as always, write that summary for me. Reflect on what we talked about, any tricks you specifically want to remember, and then come back ready to do your practice work.